Welcome back, everyone. Hope you're doing well. We sure do miss you. And I hope that distance learning is, that you're hanging in there at least. I know it's not ideal, but we're making the best of it. Today we're going to continue on studying about magnets. And specifically today, we're going to study a great big magnet that is all around us. Yes, our very own planet Earth. And it's a good thing it's a magnet, as we'll find out, as that is a critical thing to our very survival. If you recall earlier this year, we learned a little bit about why the Earth has this magnetic field. And we talked about the interior of the Earth and how the Earth has got a crust, and then below the crust is the mantle. And then below that, inside the very inner part of the Earth, is called the core. And there's an inner core, which is solid iron, but the outer core we believe to be this flowing molten iron. And this flowing molten metal iron creates this electrical current that develops in what we call our magnetic field for our planet. And that is a critical key. The magnetic field then, of course, reaches out into space from our planet, and we call that area that affects the magnetosphere. And the magnetosphere is very much just like a bar magnet with a north and south pole, just like we have, except the field lines, of course, they're reaching out into outer space. So the magnetosphere is critical for us, as we'll find out. Magneto here wants world domination, but as we'll find out, magnetosphere saves our lives. Because surrounding our planet, we have this magnetic field, and that protects us from what we call solar wind. The sun sprays all these nasty particles and ions our way, and microwave radiation and so forth. And without the magnetosphere, those things would reach our planet, and well, we would burn up, be in big trouble. But instead, it reaches out and acts as a force field. It surrounds the planet, and the solar wind then is going to be deflected around us, and as the image there below you indicates. It's also the reason that we have these beautiful color displays called auroras. If you've been fortunate enough to actually see one, see the northern lights, you've seen these ions from the solar wind get sucked in and burned up in our atmosphere, in our ionosphere. And you see that happen, of course, out towards the Earth's magnetic poles, where the magnetic pole is the strongest. In the northern hemisphere, the northern lights is what we call the aurora borealis, and the southern lights, if you were down in the southern hemisphere, is called the aurora australis. And the Earth's magnetic field, of course, is also extremely critical for navigation, finding our way around from one place to another. Migration of animals. You know, the birds fly south for the winter, and we marvel at how they find their way back each year, and how they were able to do that. Well, a lot of that has to do with using their own internal compass that they have to find which direction to go. Speaking of compasses, that's of course what we use for navigation in a lot of circumstances. We understand how we use magnetic north as kind of our starting point, and we're able to head off in bearings from there. Let's take a quick minute and see how a compass works.
We're all familiar with the idea that the compass needle points towards the north, or at least magnetic north, which is very close to our North Pole. And so here you see I've got my compass needle and the pointing right into at the N on my compass. But obviously we don't always want to go north. So if I want to change my direction where I'm heading to, my bearing where I want to go, maybe I want to go out towards the river, notice, hey, now the compass needle is still pointing towards north. I got to turn it. Sometimes you hear that idea, red in the shed. That would be the little arrow inside there. And then you turn it, and then you can read your bearing. Here, due east is just over about 90 to 90 degrees. If I want to go south, I turn my body again. Compass needle still points towards the north. I spin it until it's in the shed, and then I can get my new bearing. and so forth. I can go all the way around. You see the bearing goes all the way 360 degrees. Now I'm heading off to the west. I look up, the sun's starting to set, and I spin all the way back around, and we're back. Point towards the north again.
So we have this compass needle pointing towards magnetic north. One of the interesting things is magnetic north actually moves around a little bit. It is not in the same place all the time. It's not a constant. In fact, our magnetic North Pole has been where the South Pole is now. And that's an interesting phenomenon as well. Next, we're going to watch one more little video clip about the Earth's magnetic field and how it works and how some of these changes take place. After that, you got your quick quiz, and we'll see you back tomorrow.